Today we will discuss about trees data structure. We have already seen linked list, right? It will be like this. Suppose let's take double linked list. So then it will link like this. So it will have data, right node, left node, same data, right node, left node, data, right node, left node. Which is here it is linear. For suppose if I have designed like this, data, right node, left node, if it is connected like this, we will call this as tree data structure, where the connection will be, there will be root. All these are these arrow marks can be called as branches, and every uh, there will be an parent will have the child, and the bottommost we call as leaf. The tree is here is non-linear data structure. So that is how it will be connected. For example, this is root. So here this is will be connected at root dot left. It will be root dot right. Again here it will be root dot left, root dot left dot right, root dot right dot left, root dot right. So that tree will be look like this, and it will follows the hierarchy. So we here it will be like the it is level 1, it is level 2, it is level 3. Like for this reason where you will see depth, height, like that. And now we will discuss what is a binary tree. Binary tree is simply nothing but we will have the branches like this, only two. It can actually, a tree can have n branches. If it is n equals to 2, we will consider as binary tree. Now let's discuss what is binary search tree. That is called BST, binary search tree. For example, if you try to done one operation in arrays, that is searching. If it is 50 element you have to search, you will check one by one. So it will take order of n. Also the size is fixed. For that, if we can use linked list, but still, even though in linked list the operation times takes order of n. So here there is an idea we can use binary search tree. So in binary search tree, how will we how will it be like? There will be uh, root node value, whatever value maximum we will take here, that is this value is greater than the root, and whatever the minimum we can take at left side is the value is less than the root, like that. Again, whatever the value greater than, we will max values we will take right side, minimum value we will take left side. Now what is the advantage is, if you wanted to search an operation, you can simply take the value which is greater than or less than, so it will become n by 2. Then again, uh, again the classification n by 4. Again it will divide n by 8. So like that, your uh, searching operation is easy. You are reducing the time complexity here. Now let's discuss how to insert the values in binary search tree. Suppose if you have the values 100, 50, 200, 10, 60, 150, 300. First you will take the root value 100, then 50 is less than 100, right? So we will take here. 200 is greater than 100, so we will take here. And again 10 is less than 100 this side, and again less than 50, so again left side. Then 60, 60 less than, for 50 it is greater than, again 150. 150 is greater than 100, is less than 200, so we will take left side. Then 300 greater than 100, greater than 200, so we will take like this. So the code will be like, first we will take class node, and then we will take int key, and node left, and node right. Then we will use the constructor into value, that is key is equal to value, and left is equals to null, right is equal to null. It follows binary recursions. Now let's discuss code for insert. For insert operation, we will simply take, when if root dot key is value is greater than root dot key, means we will put that root dot right is equal to, again insert of, we will pass that root dot right and value, and root dot left, else part we will take insert of root dot left and value. The base is, when it is null, we will simply return new node, like that. For example, we will discuss implementation of the code, and again we will I will take here a class node, then int key, node left, node right. Then I will use here constructor into value, key is equal to val, left is equal to null, right is equal to null. Now I will take here node root. Actually, it is nothing but object reference. Now I will take function public insert. So I will take a node root and value. So the base condition is, if root is equal to null, I will return new node. We use the constructor part also. Else if root dot key, that is if the value is greater than root dot key, then we will simply do root dot right side we have to insert, right? So instead of I'm using the recursion root dot when it increase every operation will take helps recursion. Then again else if root dot key is less than value means I will put root dot left is equal to insert of root dot left comma value. I will simply return root. Now I will take in main method. First I will create an object. Please bst equals to new please. Then bst dot root I will pass values. That is bst dot insert of I will pass bst dot root comma 100. I will pass some values here. So let be P 150 and 125. Let me print like uh, inserting the values. So here how it works. So as per the code, it it will be simply insert like this. That first bst dot root, that is this is the root. Then we will pass the element suppose 100. Then the next time because when it is null, we're simply returning that root, right? Then if I'm passing 50, 50 is less than, so 50 will pass here. Here it will be like this root dot left, and here it will be root dot right, and suppose this is the value 150, and then if you pass 125, it will be like root dot right dot left. So now if you uh, try to do print. Now we will discuss about in order that we will try to print these elements. So for that we will simply take first we will pass through left, like that is root dot left in order of, and we will simply print here root dot key, and again in order of root dot right. It will be like this. If you add some more, it will go like this. First it will go everything the left, then it will, if it is null means we will return. So it will come back, and if it is right again it will go. I'll go and again left like this. uh, it will trace like this. I will implement that logic now. uh, I will simply take a public void in order node root. If root is equal to null, I will return. And in order root dot left, I will print the root dot key. Again, I will do in order root dot right. I'll call that function. So the printing elements we will come like this: 50, 100, 125, 150. Now we will do for searching operation. The searching operation also quite looks similar with insert operation. We simply take if root is equal to null means we will return false, and if root dot key equal to key, we will return true. The VSTs are mainly used for searching operations. We have discussed that. We have seen the time complexity has been reduced. Root dot right time. If root dot key is less than key, then we'll return set of root dot left comma key. So suppose we will check for the search operation. So if I try to search for element 100 which is there, it will show search is found. Suppose if I try to search for the element which is not there, 400, then it will show us the search is not found. Now deletion operation. So for deletion operation, that is removing node. There is some certain cases Suppose if you want to delete 60 which have no leaf nodes, then we will simply make this whatever this root uh, dot write value as null. For example, if you want to delete 200 which is as 150, then we will simply needs to replace the value. Suppose there is a certain other case, like 200, 150, suppose 300 and 170. Then if you want to delete 200, you should replace the 200 with the 170. That is the leftmost node of that right side. So we will see the implementation part for this. If you check the implementation part for removing the node, we have taken here public node remove node, and the same we have checked if the both sides is null, we will simply return null, or else if we the cases like if only left side null and right side null, and if both is not equal to null, then we will get the right get right minimum. That again I am writing that function get right minimum. So then I will do here first deleting element 100. Suppose I want to delete element 100. So first here it's showing before deletion 50, 100, 125, 150. After deletion of the node 100, we have 50, 125, 150. So this is all about the operations like insert, order, search, remove from tree operation. You can pause the video and check for the logics. This is the operation for remove node. This is our complete code. So this is all about tree data.